In this tutorial, we will be discussing how to name hydrocarbons. Okay, let's talk about the different categories again. Alkanes only have single bonds around the carbon, while alkenes have a double bond. Alkynes have a triple bond, and aromatics is a 6-carbon benzene ring, where you have 6 carbons, and then every other one has a double bond. It can be written in several different ways. It's written like this, looks like this, or if they just put a circle around it for simplicity to show that all the bonds are actually equal. Cyclic hydrocarbons all are in a geometric shape. The smallest of the cyclopropanes is C3H6. There's a carbon at each corner. Cyclic hydrocarbons are not aromatics. For instance, this is a cyclohexane where there's 6 carbons and all bonded to each other, where this is an aromatic where it includes double bonds. So let's go through these a little bit more detailed. All carbon atoms in alkanes are single bonds. The general formula is CnH2n, two hydrogens coming off of each carbon, plus 2 for the 2 hydrogens at the end. So if I have carbon, 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 each carbon automatically have 2 hydrogens. And then in order to get 4 bonds, the far left and far right, I need 2 more hydrogens. That's where you get the plus 2 from. The simplest is methane, CH4. And each atom attains an octet by sharing the electrons. The molecular geometry of methane is tetrahedral, an sp3 hybridization on the carbon atom. The most important property in is their flammability. Combustion reactions between oxygen and an alkane produces carbon dioxide and water. Alkenes are double bonds. Those double bonds make them more chemically active than alkanes by addition across the double bond. The formula for one double bond, meaning that if we had several carbons in a row and one of them just happened to be double bonded, would be CnH2n. We subtract 2 of the hydrogens for the alkane from the alkane formula for each hydrogen of that double bond. The smallest alkene is C2H4. It's sp2 hybridized on the carbon atom containing the double bond, and it's trigonal planar at that point as well. They're flammable and nonpolar, similar to alkanes, and they end in ene suffix on parent longest continuous chain, which we'll be talking about that shortly. The number in the name indicates the position of that double bond. So for instance, 2-hexene, ene, means it's a double bond. 2 on the second carbon, that 2 is that double bond. Alkynes are triple bonds. The triple bond makes them more chemically reactive than alkanes by addition across the triple bond. It's sp hybridization on the carbon atom containing the triple bond. The simplest form is alkyne, or is ethine, C2H2. It's also flammable and nonpolar, just like alkanes and alkenes. This time it ends in yne as a suffix for the parent chain. The number indicates the position of the triple bond. So these are the prefixes that you need to memorize. 1 is meth, 2 is eth, 3 prop, 4 bute. After you get past 4, a lot of them are geometric. You could probably remember them from that way. For instance, 5 is pent, 6 is hex, 7 is hept, just like the shapes: heptagon, hexagon, pentagon. For naming these, each name consists of 3 parts: a prefix, a parent, and a suffix. A prefix indicates the position, number, and type of the branches coming off of that main chain. It indicates the position, number, and type of the functional group as well. The parent indicates the length of the longest chain of carbons, or the ring of carbons. And the suffix indicates the type of hydrocarbon bonds, ane, ene, or ine. Certain functional groups are also indicated with a suffix, with the OL for alcohols and AL for aldehydes, which once again you'll be learning more about those in future tutorials. The first thing you want to do is find the longest continuous chain having a dominating functional group or bond type in that chain. The number of carbon atoms in the longest chain will dictate the alkyl group of the compound, so the base of it. So for instance, if there's 6 carbons in a row, the alkyl group will be hex. The chain is numbered so that the carbon atom attached to the functional group or bond type has the lowest number. The compound with the name 2-hexene tells you that there's 6 carbons in a row, and on the second carbon there's a double bond because of the fact that it's E and E. Organic compounds with more than one functional group will take on the suffix of the dominating functional group or the bond type. Other functional groups are designated with a number and a suffix as prefixes. For example, the longest carbon chain is 5 carbons. The dominating functional group is the alcohol group. There is also a double bond on the 4th carbon. So, 5 carbon chain, we have pent. The dominating is alcohol, so it's pentanol. On the second carbon is that alcohol group. And on the 4th carbon we have a double bond. Alright, that seems overwhelming, so let's just take this little by little. We're going to practice a few of these. First thing you want to do is find the longest chain. Notice that it bends down here as well. That doesn't automatically mean it's a substituent. We can say 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. No matter what, it's going to have 5 carbons. What I do is I circle it and then I try to name it. So I have 5 carbons in a row there. That means I'm going to use pent. They are all single bonds, so that means it's going to be pentane. Now I look for things that are not circled. Things that are not carbon and not hydrogen and not circled. And this is right here. I have 2 carbons there. So I look for 2, and I see that I have eth. If it's a substituent, I'm going to end it in YL. So instead of ethane, it'll be ethyl. Ethyl pentane. Now I need to figure out what carbon that ethyl group is coming off on. If I count from this direction, from the left, it's on the 3rd carbon. If I count from the right, 1, 2, 3, it's still on the 3rd carbon. So it doesn't matter what direction I count from. So on the 3rd carbon, there's an ethyl group on the long chain of pentane. So 3-ethyl pentane. Let's do another one. First thing I want to do is find my longest chain. 1, 2, 3, 4, 5, 6, 7, 8. Let's double check that that's our longest chain. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it doesn't matter. I have 8 carbons here, which means I have oct. They're all single bonds, so it's going to be octane. Now I'm going to go back and look at what I did not circle. I have one here, and one here that's not circled. One carbon is meth. So these are both meths. Two carbons is F. From here, I want to look at what will have the lowest numbers. If I start from the left, I have 1, 2, 3, 4. If I start from the right, I have 1, 2, 3, 4, 5. No matter what, the methyl is going to start on 2. But if I start from the left, I have the ethyl starting on 4. So I'm going to use those numbers. So 1, 2, 3, 4, 5, 6, 7. So I have a methyl group on the second carbon, an ethyl group on the fourth carbon, and then a methyl group on the seventh carbon. From here, I'm going to put it in alphabetical order. So alphabetically, eth becomes before meth. So 4 ethyl. I have 2 methyl groups, so I have 2 and 7. So 2, 7. I have 2 of them, so I'm going to use dimethyl. Notice I did not include the di when trying to organize it. I only look at the substituents themselves, not the prefixes. So 4 ethyl, 2, 7 dimethyl. I ran out of room there, so I'm going to put it down here, octane. We're going to try one more. First thing, find the longest chain. 1, 2, 3, 4, 5. 5 is pent. All single bonds, so it's going to be pentane. I have a substituent here and a substituent here. The word substituent comes from substitute. We've substituted a hydrogen for something else. That's how you remember that word. So meth, because it's 1. Meth, because it's 1. Now, from here, we want to figure out what side to count from. If I count from the left, 1, 2, 3, 4. If I count from the right, 1, 2, 3, 4. So no matter what, I'm going to have a 2 and a 4. So 2, 4. I have 2 of them, so it's dimethyl pentane. This takes practice. There's no other way around it than just practicing. So do as many as you possibly can to get proficient. And that is how you name alkanes.